This video is going to be about using dynamoDB with serverless functions. You might be asking, why serverless functions? Well, instead of having to write an API and actually having a separate server serve content from Mongo, you can use serverless Lambda functions and API gateway to basically make your job a lot easier. So that's what we're going to discuss in this video, is hooking Lambda functions to DynamoDB and actually creating some tables and consuming some data and setting some data in the table. So first you have to have an AWS account, which you can figure out that online, how to get an AWS account if you don't already have one. They have a free tier that most of this stuff that I'm describing will be free for your experiment. So once you have an account, going into the services area, you type in dynamoDB, and you go to dynamoDB, and once we're in the dynamoDB section of the website, we want to create a table. So DynamoDB is much like a MongoDB database. It's a non-SQL database, and it has records basically similarly to Mongo. Mongo has IDs for every record that are unique. In Dynamo, you have to create your own unique ID called a primary key. So we'll start out with actually creating a table, and this should start making sense after we get started. So once you're in the DynamoDB console window, you press Create Table. And for this experiment, we're just going to type in test for the table name. And then for the partition key, I'm just going to put my partition key in here, or primary key, I should say. And we're going to set that to a number. And then we're also going to add a sort key. And we're going to call that my sort key. And set it to a string. The primary key is analogous in Mongo to the actual ID. And then the sort key is what we can use to help with some sorts. We're going to keep all the settings as defaults, and we'll press create. It'll just take a little while for the table to create, so we'll wait here. We click items, and you notice there's no items yet in the table. So what we want to do is we want to press create item, and you'll have a screen here that has already our our primary key and our sort key listed. We're going to just enter some data in here. We're going to do 1 and 1, and then we want to create our data schema. That is what data sets we're going to actually have in our table. You can do that here, or you could do that programmatically, but we're just going to do that here. So in order for us to add more data to this table, we press the little plus icon, and we choose append. And then from there, we're going to choose our data set type. Now, in our case, we're going to do a JSON body, so we're going to use string. And then in this case, we're going to call our table, our JSON body, my data. All these names are important for later when I actually have some code you can get from my GitHub to actually test this out. If you want to modify the code to have different data names, that's fine. Is here. Okay. So we're going to create an item. And so now we have one item in the table. Now, the neat thing about non-SQL databases is that this table can change if you want by actually having different data in it, different data members. Generally, that can be done. It's not necessarily what you want to do, but you could. In this case, we're just going to keep the data as is. Okay, now we've created our table. Now it's time for us to actually create our Lambda function. Now we're ready to make our Lambda function. So under services, type in Lambda and go to the Lambda console. So the first step is to create a function. So we'll press create function, and then we'll choose use blueprint. And under the blueprint, we'll type in microservice. And you'll see one of the first options we have here is a microservice HTTP endpoint. Click on that. And in this case, we're going to type in test function. You can use any name you want, but this is the name I chose. And then we're going to create a new role with basic, create a new role from AWS policy templates. And down here under policy templates, we'll already have simple microserve permissions selected. If not, just type that in under this edit field here, and you'll be able to select it. For my role name, we'll just call it test function role. And then for API gateway trigger, we'll remove that. It wasn't working for me. We can add it later, and we'll create function. We're leaving the code as is for now. We can change the code later of the Lambda function. Just taking a little moment to create the function. All right. Once you successfully created the function, you end up having the function here. We don't have a trigger yet. We're going to do that next. Now there's different types of triggers that you can actually trigger your Lambda function with. So if we click on add trigger, you'll get a list of different triggers that you have available to you. Now you have all sorts of triggers you could use. We're going to use API gateway, which basically allows us to have an API out to the internet. But there's other triggers that you can use for your Lambda functions, all sorts of things. So a Lambda function doesn't have to be accessed through the web. It could be accessed within your AWS account. But we're going to choose API gateway. Okay, so from API gateway, we're going to choose a new API. And then from there, we're going to choose a REST API as our endpoint. This looks like this is a beta, so we don't want that. And then for our security, we're going to choose open. Now, you can actually do various things with IAM role or API key. Generally, you would want to use probably an API key and create an API key for your particular endpoint. But this is just an example of how to use a Lambda function, so we don't have to do anything related to that. We're not going to do any we're not going to do anything with additional settings here. We're just going to leave that as is for now. And just click add. Once you've done that, you'll notice that now you have a API gateway connected to your test function. So that's your trigger. Now let's test our trigger. So if you go down here and look, you can see that we actually already have a secure endpoint here. So we click on that, or we copy that, copy the link, and then we go into our browser and we type the link in, and then that's our API itself. But to actually access one of the functions that already exists in the API is we're going to enter some parameters right here in in the taskbar, or we're going to type in table name equals test and return. Once we do that, you can see that we actually got our data back. Now remember before when we set our table, we set up my data is here and we have a primary key of 1 and 2. And you can see that we have one item in the table and we have one scanned item in the table. So congratulations, you've hooked up your first Lambda function to DynamoDB. Out of the box, the Lambda function works great by just putting it into your Google browser bar. But this all changes when we want to write some JavaScript. And the reason is that uh, cores are required when you use scripts. Now, if you go to cores and you look at MDM's resource on it, it kind of basically tells you about why cores is important. And the reason is that for security reasons, browsers restrict cross-origin requests. They could inject some things into your browser, etc., and it's not great. So basically what we need to do is we need to enable cores on our Lambda function, particularly our API gateway, in order for us to be able to have our API be cores compliant. So let's go do that. To enable cores on our API gateway, we have to actually go into the test function -API down here to actually go and enable it. So when we click that, it'll open the API gateway screen where it shows all the connections that are being made through the API gateway. All right, so you can see that we have this client connection. It goes through the API gateway. It does the Lambda function and comes back. Now, if you notice, it will receive any as functions. We don't actually have cores enabled yet. So to enable cores, you just click on your test function and you choose enable cores. So in doing that, it's going to put some headers and things like that, and it's going to activate the options request. Now, the reason that this is being activated is for what's called pre-flight. So we'll just leave everything as set here, and we'll say enable cores and replace existing cores headers. And then we have to confirm that we want to do that. Now, while it's doing that, you'll notice that not only do we have any, but we have options added to the test function. Now, what exactly is options? So options are a request that your script would have to send out. And it's built in typically on like Axios endpoint or fetch request in JavaScript. It's what's called a pre-flight. And so basically it sends out a command, options, and then it has some headers that come back. And then any other command after that have to match the headers. And that's how it checks cores. Now that we have the API gateway set up correctly, we can close that window and go back to our Lambda function. Now, in our Lambda function, we notice here's the code for our Lambda function. This is the straight boilerplate code from AWS for the particular Lambda function. Now, there are some problems with this code, and that is that even if we try to create a JavaScript function send to this, there's not enough in here to actually make the core's response work correctly. For example, we're not handling the options request at all. We only have one header in here, and we need to add several other headers in order to get cores to work. We need to add access control allow origin, access control allow methods, and access control allow headers, as well as add options to our switch statement here and to get it all working. So I've done a lot of the work for you already. If you go to mysoftwarejourney.com, which is my personal blog, I have this whole thing described in Lambda and DynamoDB post. And I have the code here as well as on my GitHub. I'll have those links down below. So if we go down here to all the steps we've already done, and we get down to the actual Lambda function, we'll see that I've added these headers. and I've added options. So these are the only changes that I've made to the Lambda function. So we're just going to go ahead and copy this code and replace the Lambda function with this code. So what am I changing here again? Let's repeat the description again so that I can explain it better. So I'm just going to go ahead and replace all this code in the Lambda function with the code from my blog post, or you can also go to the GitHub and get it. So what we've done here is we kept everything the same. We added these three headers. So this first header is what client is actually going to access this. Now, if you were to do this for yourself, you probably would put your website client in here specifically, like www.anywhere.com, and basically you would probably change these depending on what methods you have. These are the standard methods. And then you would add this options item here so that you can check the pre-flight. So it will just respond with a status code of 200. And I just put a message in the body, course checked as passed. You don't necessarily need to send a body, but I just did that anyway. Once you're satisfied with your changes, click Save. The next step is to actually call this Lambda function from JavaScript. You can use Postman to test the endpoints, which is good to do too. But the key here is that cores are needed when you use scripted languages. Postman actually works a lot of times without all the pre-flights, and so it might be deceptive that your API is actually working. So if you go to my repository on JimmySoft LLC at GitHub, you'll find that there's a Lambda dynamoDB example here. And this repo has basically a very simple project. It's just index HTML and one JavaScript file to actually call it. And then we can show that in the next step. So go ahead and clone or download. I'm just going to download the zip for this project, and then I'm going to open it into brackets. You could use code also, but I'll just do brackets because it's pretty quick and simple. Okay, I've loaded the GitHub project into brackets, and you can see that right here I have the API code, which is on the client side, and then I also have the Lambda code here. It's not needed in this project, but it's just here just to have it all in one place in my GitHub. And then simply I have just an index page that is just two buttons to call the two functions in the API.js. So one thing we have to do first is we have to change this endpoint here to match what's in the Lambda function. So to go and get that, we'll go back to Lambda and we'll go back to our API gateway, and we'll copy this over and replace it in our brackets project. Now in brackets, if you hit the Thunderbolt, you'll actually get a live server connection, which you'll have a browser window. So let's inspect this and see what's going on. So right click and choose inspect. We'll go over to console. Now I already clicked this before, but let me delete that. So if I say scan my table, you'll see that it's getting data from AWS Dynamo table, and there is actually 3 items in here. I pressed the put item several times, and so it put 2 more records. And you can see the primary key that I'm using is actually a date timestamp. Not necessarily the best approach, it's just simple for this example. So you can see the JSON body that's returning from DynamoDB when we scan the tables. Now if I put items and I do that several more times, you'll see that I put several things in. An interesting thing about Dynamo is that there's this thing called consume capacity, which is listed as part of the object. In this case, we don't actually have a very big, extensive table of data, so the capacity units are 1. But when you get more data, this increases. So writes are expensive and reads are inexpensive in DynamoDB. So another thing I want to show you is the whole thing about cores. This was a real issue I had when I was doing mydynamodb.com, which is actually a hub social media app you might want to check at mydynamodb.com. I will link in the description below. But if we go to network and we actually see what's happening, you can see that we have a lot of functions here. I'm going to delete these. If I go scan my table, you'll see that there's two actual commands here. There is actually a pre-flight command where you can see that it says cores check safe to proceed. And then the second one is the actual get command that I get for the scan table. And so every table or every response here will have some functions like that. So in this case, we have the cores, and then we have the command. So basically, the fetch commands that are in my brackets project actually send out the cores options, and then it knows it's good, and then it can send out the actual get command. The post commands do the same thing. So I was having lots of difficulties, like I said before, when I was doing this because of the pre-flight. I would get a pre-flight error, and the options is what fixes all that. So if you want to see an actual project where I'm consuming more data and there's more interesting stuff about the actual consume capacity, you can look at my dynamoDB.com video. It's also at YouTube or actually the website, and you can see how that all works. Thank you for watching, and I hope you have fun with Lambda functions in DynamoDB.